But in part B, we have the graph of y is equal to the difference of functions f of x and g of x. And the fact that it passes through the point 0, 1. We're trying to find y prime of 0, the first derivative of y evaluated at 0, and the second derivative of y evaluated at 0. And then we want to determine whether y has a relative min, max, or neither at x equals 0, and to give a reason for our answer. Well, before we get into the nitty-gritties of finding the derivative there, if y is equal to, then y prime should be f prime of x minus g prime of x, right? And then the second derivative should just be f prime prime of x minus g prime prime of x. And what we're looking for here is y prime of 0 and y prime prime, or the second derivative, evaluated at 0 as well. And the second derivative is going to be evaluated at 0 is just going to be f prime prime of 0 minus g prime prime of 0. Anyway, this sets the stage, and this tells us before we start looking at all of the details of what we're trying to find, all we really need here is the first derivative of f at 0, the first derivative of g at 0, the second derivative of f at 0, and the second derivative of g at 0. And then we can calculate everything from there. So this might be a good time to bring in the two functions, f of x and g of x. So what we're really looking for is f prime of x, and so I will take the derivative of each term. So for f of x, f prime of x should look something like negative 1/2 plus 4x over 3 minus 9x squared over 4. The second derivative of that, since the derivative of a constant is 0, is going to be 4/3 minus 18x over 4, etc. And at this point, we're ready to talk about what f prime of 0 would be. When we plug in 0 for x, all that's going to be left is the negative 1/2. And when we do the same thing for the second derivative, all that's going to be left is 4/3. Alright, so let's go to g of x. G prime of x is going to be negative 1/2. And the next term will be 2x over 4 factorial, which is 24. The next term will be 3x squared over 6 factorial, which is, let's just say 6 factorial. Alright, it doesn't really matter because when we plug in 0 into that, we're going to get negative 1/2. All the x terms will zero out. When we go to find the second derivative of g, we have that as 2/24, which is 1/12, minus 6x over 6 factorial, and the 6 and the 6 factorial will cancel, and it'll be x over 5 factorial, which is 120. But it's not going to matter, it doesn't make a difference, because when we plug in x equals 0 to that, we're just going to be left with 1/12. Alright, so we have all of our pieces now. We want to find y prime of 0, which is f prime of 0 minus g prime of 0, so that's negative 1/2 minus negative 1/2, which is equal to 0. And y prime prime, or the second derivative of y evaluated at 0, is f prime prime of 0 minus g prime prime of 0, and so that is 4/3 minus 1/12 for a total of 15/12. So we found those. Now we want to determine whether y has a relative min, a relative max, or neither at x equals 0. Well, it'll have a relative min or max if the first derivative is 0. It could have a relative min or max when the first derivative is 0, and it is. Now, using the second derivative test, recall that when the second derivative is positive, the function is concave up. When the second derivative is negative, the function is concave down. Since the second derivative is positive, the function is concave up, and that means that the zero derivative is a minimum. So y has a relative min at x equals 0 because y prime of 0 equals 0, y prime prime of 0 is greater than 0, the function is concave up, and the zero derivative is at the bottom, or the minimum of that.